Hello students, me Kranti, the director of Success Academy. From today onwards, I'll provide you the series of physics of class 11th and class 12th later on. The class 12th will be later on. First of all, I'll provide you the series of class 11th physics as well as mathematics, so that all the students who are not going in any tuition classes or the coaching center, they must get benefited from our academy free of cost. And it will be helpful for your academic point of view as well as for your competition examination point of view also. So let's start the motion in plane. The topic is uniform circular motion. See here, a word is there, a uniform. So the first question arises, what do you mean by the uniform is? Here the uniform means someone must be constant. But what will be? If there is a motion, then definitely we are considering that here the speed is constant. Means the magnitude of velocity will also constant, but the direction of velocity will never be a constant, because in a circular motion, in each and every point, the velocity is going to have different direction. That's why the speed is constant, but velocity is never constant. So here let us consider a circular path. We have a circular path. Let us consider another body. Body is going to have a circular motion around it. Okay. And let at any instant of time the body having a velocity, that is this arrow is showing the velocity at that point. Let us consider v1 and let us consider this velocity v1 at point A. Now this body is going to have a circular motion. Let us consider at point somewhat at point B, it attains the velocity v2, and this is the velocity v2 vector. And we know that if there is a requirement to draw a direction in a circular path, we must have to draw a tangent to the circle. That's why here this velocity v2 will be. Is this clear, students? Now let us consider that this point A and this point B, it must show with respect to the center of circle having a position vector. Let us consider this is the position vector for velocity v1, and again a position vector for velocity v2 with respect to the center of the circle. Now as velocity is going to be changed from point A to point B, means definitely there must be a change in velocity, as well as if position vector is going to be changed from point A to point B. Now see here, from this point A to point B, the position vector is respectively position vector r1 and r2, means definitely there must be a displacement. Now see here the displacement, this is the displacement AB, and let us consider the displacement is del r. But now here the body is moving along a circular path, means definitely it must attain some angular displacement. Now this angular displacement having angle del theta. Okay. Now if velocity from point 1 to point B, it is going to be changed, means there must be a del V. So let us consider, first of all, I am going to draw a parallel velocity v1 here. See, this is the velocity v, this is the parallel vector with velocity v1. Now again I am going to draw a parallel velocity vector for v2. See, this is, now we have to just show with this letter v1 and it is v2. Means definitely if velocity is going to be changed, means there must be a del v. Now del v in which direction? Then we have to use the triangle law vector addition. Triangle law vector addition says that del v equal to vector v2 minus vector v1. See here, this is del v. But see here, this del v having a direction towards the center of circle, and in this manner you can say that the change in velocity will be towards the center of circle, that we have to consider about it. Okay, now if there is a change in velocity, then there must be acceleration also. Then what will be the acceleration? The acceleration will be here, this del v divided by del t, and this is the average acceleration. This is what? Average acceleration. Now let us consider that time del t tends to 0. Then what happens? Then definitely the acceleration will be considered as instantaneous acceleration. Instantaneous acceleration. Now another, we have to find out the magnitude of the acceleration. What it will be? See here, the magnitude of acceleration will be, the magnitude of acceleration will be vector A equal to limit del t tends to 0 modulus of del v divided by del t. Now this is the instantaneous acceleration. Why? Because here the del t tends to 0. Now since del t approaches to 0, then angular displacement, that is del theta, is also approaches to 0. If del theta is approaches to 0, then angular displacement is given you by modulus of change in velocity divided by magnitude of velocity. And we know that the magnitude of velocity remains constant. That's why you can also write it down like this: modulus of change in velocity divided by v itself, because the vector v1 having a magnitude v and v2 is also having a magnitude v, because there is a uniform circular motion, means the speed remains constant, means the magnitude of velocity remains constant, but direction is not. That's why velocity is going to be changed. Now also we know that the angular displacement, that is this del theta, is given as modulus of del r divided by divided by this vector r. Now this is what? This is the angular displacement given as change in position, that is the displacement, here the displacement del r, divided by magnitude of position vector r, because theta is approaches to 0. If theta is approaches to 0, then the angular displacement is given as del r, modulus of del r divided by the magnitude of position vector. Now here you can also write it down as del theta is equal to del r. This is the magnitude, and here the position vector r1 is nothing but the radius of that circular path itself, that is r. Now see here, the del theta is given as modulus of del v, vector del v divided by v, and del theta is also given as this del r by r. Then it can also be considered as modulus of del v upon v equal to modulus of del r upon r. Okay, now here you can see that the conclusion that the modulus of this del v is equal to v by r into modulus of vector del r. Okay, is this clear to you? Now putting this value in this equation, here it is the equation, that is this equation is considered as equation 1. Then what will you get? Here you can get that now the modulus of or the magnitude of acceleration is given to you as limit del t tends to 0, put here v by r into modulus of del r divided by this part del t. Here it is the acceleration given to you, and it can also be written as v by r will be constant because velocity is constant, uniform circular motion is there, and radius of the circle will also be constant. That's why take it as a common. Take it as a common. What it will be, see here, v by r into limit del t tends to 0 and this modulus of del r divided by del t. I think it's clear right now. Since again, see here, since del theta is approaches to 0, means the angular displacement, this is the angular displacement, means the angular displacement is approaches to 0, means not equal to 0 but it approaches to 0, then what happen? If del theta is approaches to 0, then this position vector del r will become approximately the linear displacement. Then this linear displacement or the linear distance is equal to speed into time or the velocity into time. That's why it can be written as modulus of del r vector equal to v del theta. Okay, and it is approximately. Why it is approximately? Because the del theta is approaches to 0. Now from this equation, the modulus of vector a is equal to v by r limit del t tends to 0 modulus of del r vector divided by del t. Now put the value of this modulus of del r vector to this equation. Let us consider this equation as equation 2. Okay, now consider this vector as vector 2, this equation consider as equation 2. Then we have then equal to v by r limit del t tends to 0 v del t divided by del t. Now put the limit del t tends to 0, then you can have the value of acceleration equal to v into v, that is v square by r. This is the magnitude of the given acceleration, which is the requirement of our today's topic to find out. But see here, students, here the acceleration is what? Since the velocity, the change in velocity is going towards the direction of the center point of the circular path, and because of that the acceleration will also goes towards the center of the circular path. And since the acceleration is going towards the center, because of this acceleration is called as a centripetal acceleration, and that's why I am here writing as subscription C to show that it is a centripetal acceleration. Okay, now let us consider the equation 3. Let us consider as equation 3. Now what happened if body is moving in a circular direction? The body is moving in a circular direction, and definitely it must have a angular displacement. If it has an angular displacement with respect to time, then there must be an angular speed. Then what this angular speed is? Now here the angular speed is given as omega. This is the angular speed given as angular displacement divided by the time taken del t, and it is the angular speed. Now omega equals to del theta by del t, and let us consider that as del t tends to 0, means time is going to be small, very small, means definitely the angular displacement to be covered should also be small. Means here you will get the angular displacement, that is del theta, should also be what? 0. If del theta is also going to be 0, means the angular displacement what we have will become the linear displacement, then implies del s equal to velocity into given time, that is del t. Now from here you can write it down as v equal to del s divided by del t. Also you can write it down as del s is the linear displacement just because of del theta is approaches to 0. If del theta is approaches to 0, means definitely the angular displacement, this angular displacement will approaches to the linear displacement approximately, and that's why you can write it down in the manner that this implies velocity equal to r del theta divided by del t. Now see here, del theta divided by del t is nothing but the omega itself, that is the angular speed. That's why v equal to r into omega, or write it down as omega into r. This is the important relation for your competition examination for solving any question with regard to numerical part. Now as we know that the centripetal acceleration is v square by r. Now putting the value of v, you will get omega square r square divided by r, or finally you can write it down as omega square into r. This is the value of centripetal acceleration. So always remember it. Now dear student, take case 1. What happened if we are considering the whole path to be covered? If whole path to be covered means the proper distance to be covered is nothing but the circumference of the circle. Then the velocity, the case 1, if the distance to be covered is case 1, if distance to be covered the whole, then definitely, and having a velocity, let it be vector v, and this r radius of the circle, and it is going to be changed from position A to position B. Let it be given as vector v2 and it is vector v1. Then what will happen? The whole distance to be covered is nothing but the 2 pi r. Then the velocity is given as 2 pi r, that is the distance traveled divided by the time, and let us consider the whole time taken is denoted as capital T. That's why you can also written it like this: velocity is equal to 2 pi r into 1 by t, and here the 1 by t is nothing but the frequency itself, or you can say that it is the revolution per second or per unit time, means how much the number of revolution the body is going to have per unit time, and therefore here the velocity can be written as v, can be written as 2 pi r nu. So again here it is an important relation for you all, 2 pi r nu. Now putting the value for omega, what you will get? As we know that omega equals to v by r, see here from this equation, omega equals to v by r, then omega will become 2 pi r into nu divided by r, means finally you can say that 2 pi nu. This is the relation for omega. So centripetal acceleration will have the final equation as centripetal acceleration will be given as AC equal to, put the value of omega square into r. Omega square means 2 square, that is 4. Here it is what? Pi square, and here it is what? Nu for 1 by t, that is nu square into r. This is the final relation for centripetal acceleration if body is going to have a circular motion with uniform speed. The centripetal acceleration is given to you 4 pi square nu square into r. And students, it's all about your centripetal acceleration. But one thing more we have to consider here, that in previous slide I had said to you that this del theta is the angular displacement, and this del theta angular displacement is exact equal made by this two vector v1 and v2 also, means both the angle will be same. Why? Because vector v1 is perpendicular to the position vector r1 and vector v2 is perpendicular to the position vector r2, and that's why at last when you will find that this del v, vector del v will also be the perpendicular to del r, and as a result we will get the angular displacement del theta will also equal to the angular displacement of in between these two vector v1 and vector v2. And students, it's all about uniform circular motion. I have to go. Thanks to all of you. Thank you, student.